We are talking about the quadratic formula, and we want to solve quadratic equations using the quadratic formula. So it says solve the following equations using the quadratic formula. We have 7x minus 5x squared minus 4 is equal to 2x plus 3. And the first thing that we want to do is make sure that we have one side of the equation equal to 0. A good way to decide what side of the equation should be 0 is based off of the lead coefficient. So the lead coefficient is going to be a coefficient that's with the x squared, and we always want that to be positive. So right now it's negative, and if we add 5x squared to both sides, then we'll have a positive lead coefficient. So that's what I'm going to do first. So I'm going to say 7x minus 5x squared minus 4 is equal to 2x plus 3. So I'm going to subtract 7x. I'm going to add 4. And I'm going to add 5x squared. So positive 7 and negative 7 cancel. Negative 5 and positive 5 cancel. Negative 4 and positive 4 cancel. And so we're going to be left with negative 5x plus 7 plus 5x squared. And that's going to be equal to 0. And then what I want to do is I just want to rewrite this so I have it in standard form. And so I'm going to write down 0 is equal to, lead term is going to be 5x squared minus 5x plus 7. And so I can now figure out what my A, B, and C are. I know A is equal to 5. I know B is equal to negative 5. And I know C is equal to 7. So I can substitute those values into the quadratic formula. And I'm going to write down, we got x equals negative, and then the b is going to go in there, plus or minus. We're going to get b squared minus 4, and that's all under the radical, and that's all divided by 2 times a. So in this case, our b value is negative 5. So negative 5 gets substituted in twice. Our a value is 5. So 5 gets substituted in twice. And our c value is 7. And that just gets substituted in once. So now we can write down x equals, and negative times a negative is a positive, so that becomes 5, still plus or minus. And we have the square root of 25, and then that's going to be minus 140. And then that's all over 10. And we can write that down. 25 minus 140 is negative 115. All over 10. And now we know that we have a negative as the negative under the radical as the discriminant. And at this point, we know that we're going to have an imaginary answer. So I can write this down as, I can split the 10. So I can distribute the 10 to both the lead term here, which is 5. So 5 divided by 10 plus or minus. And then we can write down the square root of 15, or the square root of 115 divided by 10. And then that negative comes out as I. So this is the answer right here. And we can take a look at the next one, which is already set up for us. We don't have to, like this one, we had to get 0 on one side. This one, 0 is already set, so we don't have to do anything there. So we can actually just go right into solving that. After we identify A, B, and C. So our A value is 1. Our B value is -6. And our C value is 4. So we can substitute those values in. So we get x equals negative plus or minus the square root of b squared minus 4, and then that's all going to be divided by 2. So that part of the equation never changes, and we're going to substitute in a -6 for b, and our a value is 1, and our c value is 4. So we can simplify. So we get x equals negative times a negative is a positive. -6 squared is 36, minus 4 times 1 times 4 is 16. And that's all divided by 2. 36 divided by 16 is 20. So we get x equals 6 plus or minus the square root of 20 all over 2. Now we can reduce the square root of 20. We can write this as the square root of 4 times the square root of 5. And we know that the square root of 4 is 2. So 2 square root of 5. So we can say x equals 6 plus or minus 2 square root of 5 divided by 2. And then we can rewrite this, we can distribute this 2 to both terms separately. So we get 6 divided by 2 plus or minus 2 square root of 5 divided by 2. And what that ends up being is 3 plus or minus the square root of 5.